All right, so section 5.4 has other distributions. We're going to talk about 4 other ones, but for this little video, we're just going to do one. Okay, we're just going to do the multinomial. The multinomial distribution is similar to binomial, but it has the advantage of allowing one to compute probabilities when there are more than 2 outcomes. So instead of just having P and Q, it'd be like we have PQRS, okay? So we have more than one probability. Those probabilities have to add up to 1, and then we use those to find other probabilities. So we're going to have more than one probability. Now, instead of calling them PQRS or P and Q, they call them P1, P2, P3, P4. So these are all of our probabilities down here. And the ... just means we could have as many as we want, really. But all of these P's are going to add up to 1, okay? And this is the formula you actually have to do to find the probability of X, exactly 5, exactly 12, exactly whatever. So it's a little bit smushed in there on my screen, so I'll rewrite it on the next page, but you actually have to use this formula. We're not going to cross it off. There is no multinomial PDF on our calculator. I wish there was. You have to do n factorial, and then you divide it by all of the x's factorial, and we'll put parentheses around those. And then you take each probability raised to each x value, and you multiply by each of those. So it's a little bit crazy to first set up, but once you do a couple, I think you'll find that it's not that hard to use. But we just got to be able to make sure we plug in the numbers in the right spot. And the biggest thing that people do is they get the p's and the x's mixed up. Okay, x's are whole numbers, right? Our x values were whole numbers, weren't they, in our tables? And p's are probabilities, so p's are decimals. Okay, so the x numbers are all going to be whole numbers, and the p numbers are all going to be decimals. So this is, I can see it a little bit better on here, and I didn't show out the work, so we're going to show out the work on here, but this is the answer we want to get. So in a large city, 50% of the people choose a movie, 30% choose dinner and a play, and 20% choose shopping. Do you see how it's not just 50-50? Well, you got a 50 and a 30 and a 20. So it's kind of like this would be like P, Q, and R. We don't just have probability of success and a failure. We have all 3 different things, okay? So these are each our probabilities. If I'm going to label these, this first one would be like probability 1, this would be probability 2, and this one would be probability 3, okay? Just so that we can kind of, I always do them in order of which they show up in the problem. It says if a sample of 5 people is randomly selected. So what's that? That's n, number of trials. That's our n right there, 5. That's our big number, okay? Find the probability that 3 are going to a movie. So this is our first x value. So we'll call that x1. x1 is 3. x2 is 1. And the third x value is also 1. Okay? So x1, x2, and x3. So let's plug them into this formula and see if we can get typed into our calculator correctly. So n is 5, right? So it's going to be 5 factorial divided by, and we're going to find the factorial button again on our calculator. On the bottom here, we have to do all of these times together. So what do you need to do? Put parentheses around these things. So in the formula, mentally you got to do this because it's divided by all of that. So divided by parenthesis, we need each x number with a factorial. We only have 3 x numbers, so it's going to be 3 factorial, 1 factorial, 1 factorial. Now here's the lucky thing. 3 factorial times 1 factorial times 1 factorial. I can almost do that mentally in my head without having to type that all in. Okay? Do you remember what 3 factorial was? That's 3 times 2 times 1. And 1 factorial is just 1. And another 1 factorial is just 1. So why would you type all that in? I don't know. You can if you're just one of those people like, I have to type it all in. That's fine. But mentally, I can do 1 factorial is 1. 1 factorial is 1. 3 times 2 times 1 is 6. So all of this is just 6. Not 6 factorial, just a 6. Okay? So I'd probably just type that in as 5 factorial divided by 6. And then we're going to times all that by each probability raised to each x value. Now you got to match them up. So our first probability is 50%. That was for movie. And the first x value was also for a movie. So that was 3 for a movie. So that's right. So 50% 3 times. So 0.50 to the third times the second probability, which was 0.30 to the first, times 0.20 to the first. Okay? So each probability has to be written to each x value correspondingly. And then you hit enter, and hopefully you get a 0.15. That's what they said it is, rounded. If you don't remember where the factorial button is, you can always do it out longhand. Or, okay, it's like this. It's under the math button, and all the way over to probability, it's number 4. Okay, so 5 factorial divided by parenthesis 3 factorial times 1 factorial times 1 factorial, or I'm just going to write 6 because I'm too lazy to write all that in there, times 0.5 raised to the third times 0.3 raised to the first times 0.2 raised to the first. Anything raised to the first powers itself, so I wouldn't have to put those ones in there either. Okay, and the answer is 0.15. So there's a 15% chance that that would happen if I asked those 5 people. I don't see a whole lot of purpose in finding this kind of statistics. This type of problem seems really like silly to me. When I read it, I'm like, we're just putting numbers into a formula. True. But this is part of one of the learning standards I'm supposed to teach you. So I will teach you the formula. You can plug it in. I don't see a whole lot of purpose in this, but I don't know where. In other words,